Today I want to give a small demo on the topic of strings and what are its types and what happens internally when a string gets created. So before going into my actual topic, I want to give a small brief about the object creation in Java. How an object gets created, and when the object gets created, what internally happens in the memory, in the RAM, in the JRE. So I think this object creation through the memory perspective is a prerequisite for the topic that I have called uh, chosen today, that is the strings. Now when see, this is the outer rectangle is our RAM. Let us suppose it like that. For any program or any application to get executed, it must be loaded into our RAM. Nowadays we have a multitasking operating systems. That means, and this operating system is capable of uh, executing multiple programs at a time. That means I can watch a movie, I can browse through a Chrome browser at the same time, I can play songs at the same time, and also I can play a game in the same computer at the same time. So as I told you that a program, if it has to be executed, a program or an application, if it has to be executed, it must be dragged into or loaded into the RAM. So uh, that applies for the Java program also. So if our Java program has to be executed, it also has to be on RAM only. So it is evident that our Java program cannot occupy the entire RAM, because there are the RAM is reserved for many other programs that can be executed at that time. So a specific location, a specific region will be allocated to each program to get executed. In the same way, there is a special region that is allocated for a Java program to execute itself. So that special region for a Java program to get executed is nothing but our JRE. JRE stands for Java Runtime Environment. That is what I have shown here. The outer rectangle stands for RAM and the inner rectangle is JRE. And this inner rectangle or the inner region JRE, which is meant for a Java program's execution, is further divided into four blocks. One is a code segment. This is the code segment. This is static segment. This is heap segment and the stack segment. Now my purpose is to give you a demo on what happens internally when an object is created. So in this process of object creation, code segment and static segment does not get involved. So my area of study would be the heap segment and stack segment. That is what I am going to show you in the next slide. Here I have taken a simple Java program which has a student class, and the student class contains student ID, SID, and student name. The student ID is of type integer and the student name is of type string. Now what I have done, I created a um, main class which has the main method, and I have created an object of this student class. Now what happens? See, the moment you tell new, the JVM gets activated. JVM gets activated, and what it does is it it um, it just searches for the moment you tell new, it understands that it has to create an object. Now it searches for what is the type of the object that I have to create. So obviously you have specified here that you have to create an object of student class by specifying the word student here. So obviously a student classes object would be created here by the JVM. And where, if you ask me, it will be created on the heap segment. Now I am showing that pictorially to you. See, as I told you earlier that my area of study would be stack segment and the heap segment. So that is why I have enlarged these two segments over here. This 1000 has come here by mistake. Please ignore this. And what happens is the moment you tell new student, it goes to the student class. This constructor's name would be the same as the class name. So it understands that it has to go to the student class and it goes there, and it checks if there were any instance variables over here. And now here there were two instance variables, which is int. As instance variables, they are directly created in a class, so they are called instance variables, and these two variables will be allocated memory on heap. See, now the next thing it does is it allocates a new block of memory for the object creation. See, the moment it allocates a memory, that means the object got created. Now inside the object, it allocates memory for these two variables. That is what I'm showing here. As this is an integer type variable, its default value would be 0, and as this is a string type value, its default value would be null. So JVM not only creates an object for us, but also initializes the instance variables of that object with the default values. This also is taken care of by the JVM only. Now the next step what we have done is, uh, here we have created a reference called s1 to the student object. So this student object's reference gets created inside the stack segment, and what it does is this address of this memory blocks, I mean the address of this object is, this sits inside this reference. Now this reference starts pointing towards this object that is created over here, and this object's name is s1. That is what we are showing here. So when the first line of code got executed, there is so much of process that is happening inside the memory. Now what happens is, we have now that we have created an object of the student class, we can access the elements of the, I mean any variables of the student class with the help of that object. So what I did is, s1 dot student id means, so in the student object, go for the s1 variable and assign it with 100. That is what I'm saying with the help of this line. And we go to the s1 object with the help and assign the s name of that object to Venkat. That is what I'm saying, and I'm simply printing its value, and the output would be 100 and Venkat. That is how an object gets created inside the memory. And now I feel this is a prerequisite to know what, um, uh, I mean how strings works in inside the memory. That is why I have told you this. And now coming to the main part, that is the strings in Java. Unlike any other programming languages, strings in Java are objects. So if you want to create a string, you have to create an object of the string class. The string class is inbuilt in Java, so you have to create an object of the string class. Then it means that you have created a string. So I feel before diving into the main topic, strings, I feel there is a necessity of knowing what are characters. See, everything that is present on your keyboard, including in fact the space bar which is present over on the keyboard, it is also considered as a character in Java, including all the special characters. Now and if you come to the definition of string, a string is a collection of characters. So in the definition of string, the word character is used. That is why I I felt like I have to define what is a character first, what is a character, and then I came to the definition of string. Now, if you think that the subject of strings is over, you are wrong. See, the string is a collection of character, and the character data type is a single character, that we have understood. But you are a human, so you can understand that this is this C. If you this single character C and ampersand, this dollar sign is a character, and Java, FLM, string, these are strings. You can understand this because you are a human and you have thinking capability. But uh, a computer, a machine cannot understand that this is a character and this is a string. So you have to specify that this is a character and this is a string. That means, in order to do that, there is a way in Java. See, if you want to specify that this is a character, you have to enclose it with a single quote. If you want to specify this is a string, this Java is a string, then you have to enclose it within the double quotes. That is what I'm showing in the presentation here. Character is enclosed with a single quote. String is enclosed within a double quotes. Now, right from the beginning, I kept on saying that strings are objects in Java. That point I am just reminding you, just to make sure uh, we are on the same page. Now, the definition. What is the definition of the string? Now, I have told you some points, so all those all those points will be combined here, and we will define what is a string. Now, I told you that strings are collection of characters, and also they have to be enclosed within the double quotes, and that is what I am. That is how I am defining a string over here. Strings are collection of characters enclosed within double quotes. And now that we have seen what a string means, what a character is, what are objects, and how are objects created inside the JRE and heap memory and stack segment, everything we have seen in detail. Now let us go into the further topic, which is types of strings. Before going into the types of strings, I want to make you clear that Java, from the beginning, it's an object-oriented programming. Why it has chosen that way? Why it has chosen to be an object-oriented programming is that it considers Java considers everything in the world as objects, and every object belongs to a particular type. So, in the same way, that means what it is trying to do is, it is trying to copy the real world scenarios, real world problems, real world use cases, and it Java tries to the developers of Java, they try to solve code the real world scenarios and real world use cases. So in the same way, in the real world, there we sometimes we need to change the string, and sometimes uh, we don't need to change the string. So this scenario exists in the real world. That is why the developers of Java thought and sat and developed some features like immutable string and mutable string. Mutable string and as the name suggests, immutable means it cannot be changed, mutable means it can be changed. See, I have put a point here. Wonder uh, why do you think we need a mutable and immutable strings? See, let us first talk about the mutable strings. See, you have created a Gmail and you have logged into your mobile phone now today, and after 3 months you want to log in into your personal laptop. Then uh, it's a human basic human psychology that we would forget passwords. That is our basic basic thing. We will obviously forget the passwords. And now, don't you think if you are not provided with a forget password option, and if you are not able to change your password and re-log in into your Gmail, would you be using Gmail account? I mean, if you use, you may use it, but it would be a difficult thing, right? As a user, you need that flexibility to change the password whenever you want. Think of this scenario: your dad have seen your Instagram password, so you may feel insecure, you may feel all your secrets would be revealed. So what you does is you want to change your Instagram password. So in this case also you want your password to be changed. So don't you think in the real world there is a necessity that and a password is obviously a string, so don't you think in the real world there is a need to change your passwords? So that is why mutable strings came into existence. And what are immutable strings? Immutable strings are the strings which cannot be changed. Now, don't you think the name on your 10th certificate cannot be changed? Your Aadhaar card number cannot be changed. There are some things in the world that cannot be changed. So for such things there is a concept, this concept called as immutable strings. Okay, now we have clearly seen what are mutable strings, what are immutable strings, and what is the need or necessity that there are two types. What is the need or necessity of two types of strings in Java, that we have clearly understood. Now my concept on the topic that I have chosen today is immutable strings. As mentioned earlier, immutable strings cannot are the strings which cannot be changed. And now before see, I from the beginning onwards, I am emphasizing on a particular point, that strings are objects in Java. So that, see, strings that are created using string class. See, string. I am saying that strings are objects. So for creating an object, there must exist a class. Only if there is a class, object object can be created, right? So there is a built-in class called string in Java. We have to create the object of that particular string class. That is what I'm saying. If you make use of that string class and create object of the string class, a string will be created, all right, there is no doubt in that. But if you create like that, your string will be immutable. So you might be wondering, is there any other way that we can create a string without creating an object of the string class? Yes, there is. That is why I have clearly mentioned here that there are different ways of creating string class. Okay, see, if you do not want to make use of string class, you can make use of other classes. That is not the topic of discussion for today, but you can make use of other classes, and if you create objects of those classes, your strings will be mutable strings. That we'll see in the next session, another session. But today we are telling we are our main focus of discussion is the immutable strings. So here, if you create an object of the string class and create a string with the string class, it is an immutable string. Now what are the different ways of creating an immutable string, that we will see here. Now I have created a character array. This character array, it has a reference called name. The name is the reference. It is so now, and we have see it. I obviously a character array I am creating. So array should always contain homogeneous data. That means same type of data types, same type of data should be stored inside the array. So that is what I am doing here. I am I am storing all the character values inside. How you know that this is a character value? Because this is enclosed within a single quotes and separated by a comma. So this this is a perfect justification for a character array. And now I am creating a new string object and passing this reference of the character array to the string object, so that if you print the string as, you will get the output as Java Java without the space between them. Now, another way of creating immutable string with the help of string class is string s equals to Java enclosure between double quotes. And this is the common way of creating a object. That means first you will say new. The moment you say new, your JVM will be activated. Your JVM gets activated, and it sees what is the type of the object that it has to create. Now, the moment you specified the string here, it understands that it has to create an object of the string class and not anything else. Now, if it creates an object of the string class, and it knows that it will initiate the object with a null value, but you have passed this value called Java, so that default value null gets replaced with the word Java, the value Java, the literal Java. And this string type reference, you have given it to collect the object, so it will be getting created on the stack segment, and this object gets created in the heap segment that we have seen in the starting of our session. So let us get into the next slide. What are these? So there are different types of comparing strings. How we will compare, what is the necessity of comparing, and that all we see in the implementation part. Now, uh, if if you compare two strings with the help of double equal to, their references will be compared, but not the object literals. Now, equals, if you see, I have told you earlier that string is a built-in class, and in that built-in class there are some built-in methods which you can use directly if you want to perform a particular action. For example, you want to reverse a string, there is a built-in method in the string class. You can use those methods to reduce your coding. So it makes our lives easier with the help of those built-in methods and all. Not only in strings, there are so many built-in methods in so many built-in classes in Java. That is how it helps us. That is why Java is mostly used in industries. And this compare to is all these four ways of comparing we will see in the implementation part, because it involves a bit of coding. These are small simple things, very simple things. So we will see while implementing the code, we will see. Now, before going into the actual thing, I did not actually enter the main topic. So before entering into the main topic, I want you to understand some core concepts or some basics about this. Now, I see, for every program will be written and saved inside our hard disk. But as I mentioned earlier, for any program to get executed, it should be kept on RAM and not anywhere else. If your program stays only on the hard disk, it won't get executed. If you want it to get executed, you have to bring it back onto the RAM. The process of copying a file, any program, from the hard disk to the uh, RAM is only called as loading. That is the second point that I mentioned here. And if you have performed after executing, you have performed some changes into it, and you have saved, I mean, you have saved the file. That means now the program, a copy of your program from RAM is pasted into your hard disk. Okay, so this process of copying something from the RAM and pasting it into the hard disk is nothing but saving. And this point I have mentioned in the first slide only. Like there is a region allocated for the Java programs execution, that is nothing but JRE, and inside JRE also the program to execute, there are four main segments. That is, one is code segment, static, heap, and stack segment. This I have explained you earlier. And heap segment and stack segment are these two segments involves in an object creation, that also I have taught you in great detail. And objects are created on heap, where this also I have showed you pictorially also. Like the references will be created on the stack segment, and the actual object gets created on the heap segment. Strings are also objects, and will be, see, why I have told you all, gave you all the prerequisites is, see, from the beginning I am telling you that strings are also objects, and I have told you that objects get created on the heap segment and references get created on the stack segment. Now that strings are also objects, so don't you think strings all also have to be get created on the heap segment? Okay. Now see, forget, please don't look at this enlarged heap segment for now. Now this I am saying that objects are directly created on the heap segment only. But now I am saying that strings are not created directly on the heap segment. Inside the heap segment also, there is a special region allocated dedicatedly for the string creation. There are two regions. See, that is a single region. So this is an enlarged version of the heap segment, and inside this heap segment there is a dedicated region that is created for the string creation. That dedicated region is nothing but string pool, and this string pool is further divided into two regions. One is a constant string pool, another is a non-constant string pool. Now, what is a constant string pool and what is a non-constant string pool? When does a string get created on the constant string pool, and when does a string get created on the non-constant string pool? These are the things that we have to see here. These are of utmost importance, and if you understand this concept, you can easily crack any, I mean, if any coding questions, if they give uh, guess the output questions that are based on strings, any question they can give you, you will be able to answer this. See, I told you that there would be two regions. One is a constant string pool and another is a non-constant string pool. These two regions. Now I am going to explain you when does a string get created in the constant string pool and when does a string get created on the non-constant string pool. This is what my objective is for the next few minutes. See, a non-constant string pool. Here in this region, a string gets created when when you create a string with the help of new keyword. I in the beginning showed you different ways of creating immutable strings. Now, if you carefully observe, in the first case, I have made use of a keyword called new, and in the third case also I have made use of a keyword called new. But if you carefully observe, in the second case I did not make use of a keyword called new. I have directly initiated the string. So that is what I'm saying here. If you use the keyword called new and then create a string object, it will get created on the non-constant string pool. If you do not use the new keyword, it will get created on the constant string pool. Okay, you may be wondering why it has got two regions, why it has to create, I mean, why one has to be a constant string pool and one has to be a non-constant string pool, and if you use the new keyword, it has to be created on the non-constant string pool, and if you uh, does not use a new keyword, it has to be created on the constant string pool. Why? The answer, all your questions will be answered now. Now, if a string is created on a non-constant string pool, it does not, sorry, in non-constant string pools, duplicates are allowed. That means if you create a string object called Java, as is I have explained you earlier, um, the string object gets created in the heap segment, and its reference gets created in the stack segment. And if you again create a string s2 with the reference name as s2, and its value is also Java only, then what happens? See, I told you that duplicates are allowed. So one more string with the I mean with the value Java gets created. But if you create a string without a new keyword, that means if you simply create a string like s1 Java, string s1 equals to Java and string s2 equals to Java. In this case, you have not used a keyword, so new keyword. So your string gets created on a constant string pool, not on the non-constant string pool. And in the constant string pool, duplicates are not allowed. Duplicates are not allowed in the constant string pool. Now, what happens is two references will be created. But only one object gets created. I'll show you pictorially by making use of some this tool. So what happens is, assume this is a heap segment, and this is a stack segment. Now assume that I am creating a string on the constant string pool. Now I have created a Java, and once again, if I see string s1 equals to Java, and string s2 is also equals to Java only. In this case, what happens is, normally what should happen, this Java, first of all, a new memory or block of memory has to be allocated on the heap segment. It has to be initialized with the value Java, and the reference has to be created on the stack. This reference name has to be s1, and the value of this address has to be sitting in this s1. And the same thing, a new block of memory again is gets created here. Its value is Java. Its reference will be, its address will be 2000 something. It's a random value, I'm saying you, and its address will be 2000. A reference s2 gets created on the stack segment. This address has to be coming and sitting in the s2 reference. But what actually here happens is, as you are creating a string in the constant string pool, and duplicates are not allowed. So once you create a new string s2 with the same initialization Java, what happens is, it checks in the constant string pool whether a string already exists with the same string already exists or not. Uh, um, but here we have, as we have already initialized the string with Java, it it says that, so we are not allowing the duplicates. So but we have uh, um, given a reference s2 to it. So what happens is, the same address which got allocated for the string s1, the same address comes and sits here in the s2. So what happens is, s1 both s1 and s2 are referring to the same object. They are not referring to two different objects. They are referring to the same objects only. So that is why I have, to prove you this, I have listed out some different ways of comparing strings that I will explain now in the implementation part. Now, in the coding, I have kept this ready just to save my time, because already it's a very lengthy recording it has become. Um, so there is nothing much I have done here. Simply, I have created a class called demo. I have created the main method over here. I have created a string s1 without using the new keyword. String s2 also I have created without using the new keyword. That means, as I mentioned earlier, I am without using new keyword means it will be created on a constant string pool. So if you are creating a string on constant string pool, I have clearly mentioned that the duplicates are not allowed in this constant string pool. So what happens, if duplicates are not allowed, it does not allow the string s2, I mean the object s2 with the same value of s1 to get created on the heap segment. Instead, it will say that, hey, already there is an object called Java that is existing in my memory, in my constant string pool. So what I will do is, I will you just create a reference s2 also. So what I will do is, I will share my object. I will share my object. I mean, I'll share my address to you. I mean, to the s2 reference also, I will share my address. So that whenever someone calls, yes, either s1 or s2, same Java will be, you will be getting same Java as output. So this is it from my side. Okay, let me execute and show this to you. Uh, so as per my explanation, both s1 and s2 are pointing towards the same object, that is Java only. So as per my explanation, this block of code has to be executed, because if s1 is equal to s1, here I'm comparing only the references, not the values, literals. So as per my explanation, uh, because I am saying that s1 is equals to the reference of s1 and s2 are equal, so this block of code has to be executed, because if only if this is false, this condition will be executed and you will be getting output as a references are unequal. But I am saying that both the references will be pointing towards the same object, so their references will be equal. So let us see this ones. Let us execute and see the output. And if you can clearly see here, the references are equal.